in this section, we are going to talk about factoring binomials. Now, do you guys remember what binomials are? Okay, binomials are usually described with more than just a single word. Binomials are polynomials that have what? Two terms, right? Now, we saw some of these guys before. We've talked about what binomials are. In fact, everything we have on the board here, these guys are products of binomials. A squared minus b squared we had in the last chapter. This is from the section on special products. Now, this came from multiplying conjugates, a plus b and a minus b. Remember that guy? That's what we had before. Except in the last chapter we were going this way, but now in this chapter we're going to factor, so we're going to the right. If you see the sum of squares, a squared plus b squared, what you need to understand is right now, this guy does not factor. It does not factor over real numbers. So if right now you see a squared plus b squared, I'm going to give you some words of advice. Okay. What? Don't do it.
I'm going to write that down.
You should. Oh, no low haggis. That's right, Mr. Craig. I will not haggis at all.
Haggis?
I know, but English Anglophones say no low haggis. Now, I don't say it that way. I tend to put a little French twist on things. Now, there are formulas for the cubes, and we're going to look at these guys more tomorrow. But I want to go ahead and put them out here so you have them in your notes. Okay. The difference of cubes is a minus b times a squared plus ab plus b squared. The sum of cubes does factor, and it factors very similarly to the difference of cubes. It's a plus b times a squared minus ab plus b squared. These are formulas that you are going to have to know because I never give you anything, nor do I intend to give you anything. Here's a little acronym that can help you remember the signs, okay? Because you notice that it's pretty much all the same as you go across here, whether it's a sum or difference. S stands for the same sign, so if it's a difference, it's a difference. A sum, it's a sum. What do you think O stands for?
Opposite.
As if it was a difference here, now it's a sum. If it was a sum, now it's a difference. And AP stands for always positive. This last guy right here is always positive, no matter if it's the sum or the difference of cubes. Now, save this guy for later. We'll get to those guys later, not right now. So I want you guys to see that these are some of the easiest polynomials that we have for factoring. Okay? If I have x squared minus 25, what I want you to see is that it's set up as one of those special forms that I wrote at the top of this page. I claim that this guy can be written as something squared minus something else squared. In essence, rewriting this guy as the difference of two squares. What are those two squares that we have here?
X and 5.
X and 5, right? So if you guys can see that and you believe that, then this is going to act as the A that's in that formula, and this 5 is going to be my B. So when I factor this guy, and a lot of times what you may want to do when you're using these formulas is that you write the formula underneath the factored form just so that you can put everything into it correctly. So if I'm saying that the formula is a plus b times a minus b, what would you write here for a plus b?
X plus 5.
It would be x plus 5. What's the other factor? X minus 5. What was that? Didn't we already do this?
Yeah.
When we did it last chapter, we were multiplying, right? Last chapter, I gave you this guy, and I said multiply that out. And you'll say, oh, these are conjugates. I get x squared, I get minus 25, but the inside and outside pieces of the FOIL would cancel. So all you have to do is identify that you have squares, and you factor it, and you're done.
We're basically going backwards.
Yes, that's what this whole chapter has been about. Instead of multiplying out, we're factoring. What are the things that we multiply to get these polynomials? Like if I have x squared minus 144. Do I have the difference of two squares? Huh? No? Isn't this a square? And isn't that a square?
Yeah, that's 12 squared.
That's 12 squares, so what are the factors here? X plus 12 and x minus 12. Now see, I don't have to write this middle step here. I can keep track of that in my mind. I know what the squares are. So it's x plus 12 and x minus 12. Now you guys may write x minus 12 and then x plus 12. It doesn't matter. I always put the pluses first because I'm a positive kind of guy. You're right back there. Why are you laughing at me? See, this is what you get for laughing. You know, it's like a jungle sometimes. It makes me wonder how I keep from going under. What? Oh, so I just write 9 over 10 over here. Squared. No.
X minus
X
9 over 10.
X plus 9 over 10.
X plus 9 over 10.
Times
X.
Minus 9 over 10.
Word. Yeah, that's why I'm a G. Yes. That's what they call me. I should make t-shirts that say that. Don't rip me off, but you know. You know, got G on one side, and then flip on the other side.
We're all waiting.
Wait a minute. It's a.
That's creative.
Yeah, after class I'm going to go and make these. Evidently, I'm going to make these tank tops because I'm not going to make a T-shirt. Evidently. Right, I got to put a disclaimer on here. So how do I factor this guy?
2 plus
2?
2x.
Just 2.
2x.
Oh, 2x.
Plus 3y.
Be positive, dude.
Yeah, 3y.
Y.
3y. If you get one factor, you got the other one.
2x minus 3y.
Could you sound any more robotic? Are there questions about these guys right now?